But basically, icebreakers are also helping to feed the polar bears. Always a lot of them around it. A lot of fish is normally just below the ice because there is a lot of oxygen there, relatively, yeah? So whenever the ice is coming like this after the icebreaker, all the fish is on top. So they're just lazy coming, walking along the icebreaker route and catching the fish from the ice.
A warm welcome back to Decouple. Today I'm joined by Aleksandr Surtcev for an exciting episode about the Russian Northern Sea Route and all of the exciting SMR activity that is happening in this region. The combination of LinkedIn and WhatsApp is truly miraculous in this modern world. I had a post not too long ago on the topic, and Aleksandr showed up in the comments, and from there it was not a long journey to being in touch, having a preliminary phone call, and here we are. So Aleksandr, it's a pleasure to have you on Decouple. Welcome aboard.
Thank you very much. I'm happy to be here. That was a lot of fun to read your post and to do some follow-ups after that.
Right. So, I don't have a great excuse here because, again, we met on LinkedIn. I should have probably looked at your profile more carefully, know your whole biography, but I've been busy recently. So, from our conversation, what I remember is that you actually served on one of the nuclear-powered Russian icebreakers. But forgive me, I know you've worked recently in the UAE on the Baraka project in some shape or capacity, but please fill us in a little bit on your background.
So basically, my education is a mechanical engineering, maintenance and repair of nuclear power plants on icebreakers. So basically, that was my profile education, and I spent 6 years in St. Petersburg in a maritime academy. And during the time, we did something like 6 to 8 months training on board. And I did the complete route from Murmansk to Pevek and back. And after that, I've decided not to follow up with the icebreakers. I did work on the merchant ships, and we did a lot of routes to Dudinka. That's just approximately in the middle of it, where Norilsky Nickel can deliver the production, yeah, and which was exported to Europe. At the time, it was Rotterdam mostly, yeah. So yeah, I've got approximately 6 months of experience on board of icebreakers, and a couple of years traveling around the world as a mechanic on board the ships.
So, yeah, I think it's important for us to orient people to a part of the world they are utterly unfamiliar with. So we're going to be talking quite a bit about the Northern Sea Route, and this runs along the northern coastline of Russia. You mentioned St. Petersburg. We're going to talk a bit about Murmansk and Atomflot, where the icebreaker fleet is serviced. And there's the Yamal Peninsula, where a lot of Russian oil and gas is produced,
Sure.
and will travel the Northern Sea Route. That's about kind of halfway along that kind of Eurasian continent, the northern sea route again. And then Pevek. People should remember Pevek because why? The world's first, or maybe not the first, but currently operating floating nuclear power plant in the form of the academic Lomonosov. So when we talk about SMRs in the West, they sort of remain theoretical objects, but very interesting things happening in this region. So have I summed up the geography? Is there anything else you want to touch on, or why again it's significant geography?
Not really. It's only Dudinka with Norilsky Nickel and Norilsk, yeah. So the Yenisei River. And that's a very specific place. We can cover it a bit later. But basically, it's nothing there. It's up to 5,000 kilometers of nothing. And it requires some specific solutions to be able to operate there. So geographically, you're pretty much okay. There is just nearby Pevek, there is a Yakutia, and they have a small port called Tixi, but that's about it.
The relevance of the Northern Sea Route, to my understanding, is that we can connect European and Asian markets, as well as oil and gas produced in the Yamal Peninsula, And essentially the distance, rather than, a vessel leaving Europe and transiting the Mediterranean, the Suez Canal, the Indian Ocean, getting over through the Straits of Malacca, lots of sort of geopolitical squeeze points there, and also just a long distance. I can't remember. I think it's high 20s, like 28 days or more. That route versus you cut off about 12 days, I understand, by taking the Northern Sea route.
Something like that, yeah.
But of course, the challenge is that the Northern Sea route's full of ice. So tell me a little bit about that history and the history of, maritime navigation in that part of the world. I think climate change is probably helping out in terms of, the ice thickness and, how long the route is completely jammed. But Russia is the only nation in the world with a nuclear-powered icebreaker fleet. And there's a reason for that. This is a strategic sea route and becoming more so, it seems, with every passing year. So fill us in a little bit more on that region, and again, the nuclear icebreaker experience. Anywhere you want to take that question.
Yeah. Look, we can say there is a space race always, and there is a Arctic race. So we have a lot of interesting stuff there, and a lot of oil and gas and different kind of metals, which China now manipulates. I read your post today about it. Manipulates their position on the market, and hence, basically, Russia took a step forward quite some time ago. And with 50 something years of experience with icebreakers, and now it is what? Generation number 4 already working on the route and covering it. And it's tough. It can be very fast. It can take only 12 days to come through the complete route. Yeah. From Murmansk to Pevek and further to Petropavlovsk-Kamchatsky. But look, I did my trip during the summer. That was August. And we had a lot of ice problems. And we were accompanied by approximately 5 tankers, which were not really well suited for the to be there. They were not reinforced tankers. Yeah, they were just normal tankers, which should stay in the Northern Sea, but do not come after the well, how do they call it?
The Arctic Ocean?
Karlov's Gate. What is it? Like the real entrance into the ice area. It comes just after Yenisei, I believe, just after Dudinka. And so basically, you recommend me to saw a video about the new icebreaker, which would be produced in 2035, leader, yeah. And that was actually a nice one and a nice project. I was making a diploma on a similar approach, and I had only one problem. So it was a very powerful icebreaker, much more powerful than anything existed, which would be able to cover 2.5 meters of ice, to break through. But my problem was the propeller, the shaft propeller. I couldn't find anything suitable. And I saw the solution now, 4 of them. Amazing. I could not get it at my time, 20 years ago, but they got it. And it solved it, because I got so huge propeller shaft, it was not operable. Yeah, I had to do it anyway, just because of lack of time, and basically, okay, I was a student. I didn't have a complete university and scientific institute covering my back, but that was an interesting solution. So it can take 12 days, but with the ships coming with us, it took us 2.5 weeks in the end. We had a quite severe ice conditions due to the wind change, and there is 2 kind of speeds the icebreakers normally have. One is the fast one, when you just going through the thin layer of ice, which is up to, I don't know, half a meter, and then it's okay to go with up to 10 knots. Yeah. And then the second one, when the ice got bigger, and then it's a different strategy, basically. You can see it. So the icebreaker comes on top, then it breaks it. Then it comes again on top, then it breaks it. And then the speed is reduced to 3 knots, something like that. And we had to change the route on the way as well. I told you the story. So we're supposed to come from the north of some island, and we had to use this island as a cover from the ice and come on the southern route. So it's almost every time 2 icebreakers because one can get stuck. And in the summer, the possibility of that is not that much. But the sooner we are coming to, I don't know, October, that can be difficult. So 2 icebreakers always. But anyway, that was fun. And we, on the back of our icebreaker, we had a oil tanker fixed with our ship. Yeah, so we used 2 winches to tighten the oil tanker to our back.
So it's like a tugboat arrangement.
And you see it on the video. You just don't understand what is this. So on the back of the icebreaker, you have a special device, basically, with some kind of steel nets. So the oil tanker can come directly into it, yeah, and will not be damaged.
Interesting.
So it's like taking a damaged car with the fixed connection, yeah, basically. So we had
Except
one.
we're talking about a huge amount of mass. Like as you mentioned, if you're going 10 knots and then you hit that thick ice and you're stopping, going down to 2 knots, the potential to get rear-ended sounds pretty significant.
We damaged the rope every second day. So we just had to cut them and fix it again. So that was fun. And one of the funny things that the chief engineer of the oil tanker behind me then was a chief engineer on the next ship I was working on as a mechanic, not a trainee anymore. So once we were talking somewhere in Rotterdam, drinking a nice glass of beer, I started to talk about this experience in my life. And he was like, when was that? Yeah, I know. I know what happened there. I was behind.
So I guess like what's really interesting about this, and we can talk about the icebreakers a little bit more. There's something like 400 years of reactor years of operation. This is quite a mature program, and this question of how to power far eastern Siberia, for instance, the Pevek region. I was really shocked to learn that there has been a RBMK, a mini RBMK style reactor, actually 4 of them, powering a very remote community, Bilibina, in Chukotka, Russia. And again, that's very, very, very far east. That where the academic Lomonosov is now, it's sending power, I believe, onto Bilibina to replace it. But in any case, I mean, this question of how do you power this region? I understand there's some coal. I hear that coal piles freeze sometimes. That can be a problem. Obviously, Russia has a lot of gas and the potential to liquefy it and run, de-liquefy it or turn it back into gas to run in power plants up there. But it looks like there is a move to take advantage of, this first mover advantage in this mature icebreaker reactor technology, and now start looking at powering remote communities, both with electricity and heat. So again, I'm famous for long rambling questions, but I guess I'm curious from a sort of 30,000 foot view, how this program has matured to the point that we're now talking about and actually deploying icebreaker reactors as power ships.
I looked through a little bit, and there was a possibility that Novatek would deliver their LNG stations instead. Yeah. But in the end, Novatek depends on the export technology, which was security-wise not stable, not comfortable. And after a long discussion, they decided to go with a nuclear program. It's kind of more expensive initially. But honestly, in my opinion, that's completely right, because we have to develop and to continue to develop this program anyway. Yeah, Russia has to do it. They're saying that Arctica in 2035 would be warm and cozy, but okay, show me in 10 years. It's not yet. And the solution is great because the logistic is easier. So whenever you have to change the nuclear fuel every 10 years, come on, that's not a big of a deal. Instead of bringing the fuel supply and be limited. So you have to deliver in time. You cannot have so much reserves. And then if you have the people working there, if you have to dig these materials from under the ground, I believe now this Siberian project we were talking about for copper and gold, it requires something like 240 megawatts of energy. So we can imagine what a stress it would be to ensure the proper logistic, especially in the wintertime. Icebreakers can come through, but not always. Even them, not always. That's why they have a leader which has much more capacity and double of energy compared to the previous type.
Yeah, so the leader is not yet built from what I understand, but we're going from, I believe the current Rytm reactors are sort of 55 megawatt electric each, two of those in the current class of icebreakers, and now going up to sort of double the size in the Arctica class, or sorry, the leader class. I guess project, I forget all the numerals behind it, but I mean, these boats are getting absolutely massive. In terms of, again, keeping this open. But I think what you were saying there in terms of, okay, if we're going to use LNG instead, you need a regasification plant. You need somewhere to store that gas for potentially long periods. And, I'm no expert on natural gas storage, but it sounds like there's the potential for supply disruption. So you mentioned potential exposure to foreign technology and sanctions being one reason. I guess, doing the nuclear approach keeps a lot of the economic benefit in Russia, given
basically
there's kind
all
of
of it. Basically all of it, yeah.
Right. So interesting sort of weighting of decision making. Again, I was reading about Bilibina, these four little 13 or 12 megawatt RBMK reactors. The northernmost nuclear power plant built on permafrost. Steam is condensed with air cooling up there, which I guess makes a bit more sense in terms of the thermodynamics. This is not the first time that this technology has been used. But I guess just, the reason I stumbled across this topic was I was giving a talk at a mining conference about, the ability to power mining operations with nuclear. And I'm pretty bearish on Western companies like Westinghouse doing land-based microreactors. In part, I mean, for many reasons, but one of the big reasons is just the incredible amount of logistics that are required to get liftoff with that kind of a program. And with Rosatom, you have this vertical integration from mining, enrichment, construction operations, decommissioning, waste handling. You have the icebreaker program. You have dedicated marine infrastructure to kind of support this program. Like, absent all of that, if Rosatom were just kind of a skeletal Western reactor vendor, this would not make sense. Like, you need the kind of inertia in the system in order to make this make sense. As you're saying, it's more expensive, but you're building off of a advantage that's been there for a long time, it sounds like.
Yeah, and whenever you produce more than one, the price is going down. So by scaling up the production, they anyway reduce the costs.
And so in terms of what's being built now, the academic Lomonosov, I'm going to blank on the name of the reactor technology, but the kind of latest reactor technology is the RITM. It sounds like rhythm when I hear Russians saying it, the rhythm. Can you describe that reactor technology? Is there anything sort of new or exciting or different about it than previous classes? Or is this sort of, I mean, things are always iterating and improving, but it sounds, again, like 400 reactors of operation. Lots of lessons have been learned. So I'm just curious about this technology, which seems to be the one that's getting standardized for the floating nuclear power plants and maybe even a land-based SMR, which is under construction in Yatukia.
I believe there are, I believe, two possibilities still. So the Lomonosov is still using the old technology taken from the icebreakers, and it's just a high-pressure water reactor. And this is a very safe technology, low maintenance, which is tested for 50 years. And the latest designs could be taking the liquid metal reactors, liquid metal cooling. But I'm not actually sure they will choose it. I still believe in the end they would go with high pressure water reactors, just because, and it's so easy to recharge it. It's absolutely easy, and in case of any troubles, you don't need to heat it up, warm it up. You don't need to have so much emergency energy source. So I believe it still would be the future. And if anyone would go in Russia with other types of reactors, that would be big station-wise power plants somewhere in a normal temperature regions with a very good infrastructure. That's my opinion, because in the end, safety is everything, and no need to change something which is working. Yeah, working reliably. Yeah, the efficiency may be a couple of percent less, but that's not about it. It is a commercial point. So Rosatom had a cheaper price for the kilowatt than Novatek in the end.
And
They
Novatek
had,
is the gas company.
yeah, they had more initial investments, but the actual price per kilowatt was out of, let's say, 9 rubles against 11 from Novatek. So long term, Rosatom is anyway cheaper.
Right. So there's a higher capital expense up front, but then the OpEx makes up for it over long periods of time. So from what I understand, there's I'm going to butcher pronunciation here, but the Baimskia, I think it's the largest undeveloped copper deposit in the world. It's near Pevek, near Bilibina. It's going to require something like 300 megawatts. And so I think the plan is for 4 floating nuclear power plants with the RITM reactors on them. And as it stands right now, the academic Lomonosov is refueled on site, and then I think every 10 or 15 years brought back to Atomflot in Murmansk to be defueled, etc. But I believe it's a different model with these RITM floating nuclear power plants, which are not going to be providing heat to any local community, but just sending megawatts down to the Bemskaya project. So these I think there's one in reserve. There's going to be 4 barges, and one will be taken back to Murmansk at a time for refueling to ensure sort of that steady 300 megawatt output. I'm just, like that northern sea route again. It's something like 4,000 kilometers from Pevek to Murmansk. You sailed it. The logistics of all that seem wild. I don't know if you want to opine at all, but it's interesting.
Yeah, correct. And one more thing about these new reactor types. We were talking about it. It would be a complete monoblock design with everything integrated in. This is the big difference for sure. All the pumps would be integrated in, so absolute minimum amount of maintenance, basically nothing, only to control the parameters. And safety-wise, it's a great development. So no need to stress out. They are able to work without any electricity income and be able to cool down themselves. And of course, after Chernobyl, it was a standard, the negative coefficient factor, always. So meaning that this reactor would just shut down himself if anything goes wild, and the logistic is, I believe it's more or less fun. It's a trouble. It's a lot of chaos, but it is some kind of tradition. Just today, I remembered one interesting thing. We did markets just in the middle of nowhere. We would stop for half a day, and then the people from all over the places, I have no idea how long it took them to get there, but they would come with the snowmobiles, and they would bring all kind of products they could make there, like, I don't know, fish, whatever.
Reindeer.
And we were delivering them the wood and some kind of stuff from the big cities. So, and this is the tradition which goes for 40 or 50 years already, meaning from a father to a son, from a son to another son. So it goes like these icebreakers. They're not just supporting these ports and PEVEC and the future mines. They are also supporting the normal people who are still living there and doesn't want to leave. Yeah, you cannot find a city there. It could be just a couple of houses somewhere. And they're also getting, of course, some fuel from the icebreakers. So that was a very interesting. I enjoyed it. That was something incredible. Yeah, in the middle of nowhere, it's only ice everywhere, and then just within 30 minutes, you have a crowded market below. And one more interesting thing, basically icebreakers are also helping to feed the polar bears. It's always
Right.
a lot of them around it, and not because we just, the condensed milk. So that's normally what people are throwing from the icebreakers to the bears because they love it. They just, and they don't need anything to open the can. They just chew it. But the other thing is that icebreaker is breaking the ice, right? And all the fish a lot of fish is normally just below the ice because there is a lot of oxygen there, relatively. Yeah. So whenever the ice is coming like this after the icebreaker, all the fish is on top. So they're just lazy coming, walking along the icebreaker route and catching the fish from the ice. They don't need to bother anymore. It's a very easy way to get yourself some food.
I mean, the animals obviously behaviorally have recognized this is an icebreaker. There's going to be fresh broken ice. There's going to be lots of fish. So they just kind of follow the boats around, or if they see you coming, they'll kind of come running towards. And
Yeah, that's correct. That's also funny. And yeah, it can take from 12 days to 20 days, but it's not a big of the problem. And you can always schedule the shipping of this power plant to Murmansk during the summertime, when it would be much easier, and less stressful. And with the modern satellite control, we can easily predict the movement of the ice fields, and basically they know the thickness. They know how big is that and how thick is that before it comes. Yeah. And basically they always can choose, okay, we can come through or we take around. Yeah. Or we go around it.
And so this new class of icebreaker, the leader, this again is sort of the souped up, twice the electric output. I think it's two basically 100-megawatt electric reactors. I mean, these boats just keep getting bigger, but this one, presumably, would it have to slow down to the 2 knots, or it can just blast through 3-meter thick ice? How does it look?
No, it would have to slow down. That just because of the steel, yeah, and not. It cannot work with the 10 knots and 2.5 meters because basically the system is different. There are Arctica style, the old Arctica style icebreakers, which were built more or less like a normal ship with the shape like this, yeah, like going down like this. And then the 2 Finnish-built icebreakers, Taimyr and Vaigach, Taimyr system, and they had a flat bottom, basically, because they were supposed to operate in Dudinka region. And this was one of the, I would say, before Yamal, it was the most important region in Siberia. So it was PEVEC. I would say it would be the second one. And Dudinka and Nerisky Nickel is the first one because it was all export. Yeah. and you basically cannot transport it any other way around it. And it works only through from, I would say, from end of April to beginning of October. Then the complete marine infrastructure is disassembled. They take it out and they reconstruct everything next April.
In terms of the port facilities, are we saying, or?
Yeah, there is no constant port facilities, nothing. They take it back. Even they have a small railroad there, so every autumn they disassemble it completely, and every spring they assemble it back. So now they combined with the leader. They combined two shapes. Because with the hard shape you have to break the ice, but with the flat shape you have to come on top of this and then break it with the weight. So now they combined it. They have two possibilities. But whenever the ice is coming too thick, you have to go on top of it. So basically, part of the ship of the leader would come on the top of the ice, and only then they have a sharp part below. Yeah, and they supposed to break it. You cannot go fast in this kind of ice. Basically, 10 knots is, I believe, the speed, or 12 knots with the leader. I believe this is the speed for the ice conditions up to half a meter. Then they change it.
You were mentioning earlier the tankers that were following the icebreaker that you were deployed on did not have a special hull. And I'm imagining, crunching through 2.5 meter thick ice, you're still leaving some pretty big chunks of ice behind you. So does this require like the whole LNG fleet to be purpose-built to have specialized hulls? Again, this is part of an enormous investment in this very strategic region to give Russia another outlet for its oil and gas to Asian markets, I guess. That's, very much under Russian control, essentially passing through territorial waters and through a route that really only they can keep open because of this icebreaker fleet. But talk to us a little bit about what's required in terms of the non-icebreaker fleet in that region for their hulls and whatnot.
They all should be reinforced, and Russia has it's still operating. It's 36 years old, I believe. The Sevmorput, the one and only merchant ship with a nuclear power plant. And they tested it for quite some time, and I believe it was in 2000 something, 2002 maybe, when Norilsky Nickel started to build their own fleet of ships, reinforced ships, which can follow the icebreaker without having the need to be fixed to it. Yeah.
Right. Okay.
So meaning more steel, more safety, and for the old type of the vessels, it would normally mean a frequent repair. It's not a big of the deal. It's normally a ballast tank which is damaged from the outside damage. Yeah, the outside hull. Yeah, when it's damaged, it's only the ballast tank, and every ship has plenty of them. I would say from 10 to 16. Meaning, okay, if 2, 3, 4 of them are damaged, not a big deal. They can still be operational, and then just the next time they're in the port, they have to fix it. So yeah, and all of the LNG ships shall be reinforced, just safety-wise, because no one can predict the conditions. And they've tested the container ship for 30 years before they decided to go on. Yeah, with this series of bulkers, and I believe Yamal now has, I don't know exactly, but I believe Yamal LNG has their own reinforced ships as well.
And in terms of the vision moving forward, I mean, climate change is playing a big role in potentially one day ice-free summers in the Arctic Ocean. But the planet is warming differentially. Temperatures are sometimes, global average temperature might have gone up by 1 or 1.5 degrees, but in the Arctic, I have a friend who lives in the Canadian Arctic, and it's gone up by maybe 10 degrees. So this means major changes. Are they foreseeing that this ice route will be navigable 12 months of the year?
They talk about it. Yeah, correct. I would be able to believe it when it would happen. Yeah, and probably I'm not saying it's not true. It is true, but it's just probably not easy to imagine. We also have some evidence that Siberia is warming up also 3 to 5 times faster than everything else, just because of magma condition below the surface. So hence, actually, Russia has a lot of fires during the summer in Siberia, and they're huge. People cannot even imagine. It could be a normal European country size
Fire.
under the fire in Siberia without any problems. Yeah, it's happening every year, unfortunately. So we will see changes are coming, and we see it slowly, step by step. And if in 10 years that would happen, great, then it would create a lot of opportunities, because even Suez is not as stable and easygoing, easy decision for anyone to use it. Absolutely not. It is a huge traffic jam normally, and some ships still have to go around it.
Well, yeah, literally, it was jammed a couple of years ago by a massive container ship, and then with the Houthis in Yemen and the conflict in the Middle East, the Red Sea has been at times closed, and I guess people have been transiting around Cape Horn, Africa, at in terms of certain flagged vessels. So it is a very interesting thing to have a second sea route that's open, and under the control of a different country than Egypt. This is hugely geopolitically significant.
Yeah, and for Russia as well, because how to export in these conditions, sanctions, political instability, this is the only way to export LNG and oil from Siberia region. And we just, I believe, you can imagine, because Russia has a lot of similarities with Canada, but I believe no one else can imagine that it's nothing there. For 4,000 kilometers, it is 99.9% of nothing, meaning that even Russians don't understand how much natural resources they have there. They can only estimate. And Arctic region, I read, has something like 20 to 30 oil and gas resources in this world. So strategically, Russia is well prepared to take over of this. We will see. Yeah, that's one of the points as well. And if the Arctic route would be cleared from the heavy ice, then the communication between Russia and Canada can be much easier. It took one brave pilot at one point, Chkalov, to make a flight from Russia to, I believe it was Canada, not United States, but I'm not sure, through the polar cycle. Yeah, so he came through the Arctics, and it was the shortest route available, and he showed that it is possible. So let's imagine we can do
This
it
must
with
have
the
been
ships.
a long time ago on a propeller plane, I guess.
Yeah, it was something like 1970s or something like that. Yeah, it was quite some time ago, maybe even before that.
It must have been before, because we had our dew-line radar system, waiting for Russian bombers to come over to the pole. So that was quite common.
No, that was official flight. That was not
Okay.
a secret one. That was totally
Of course.
official.
So I mean, this is interesting, right? So basically, the Ural Mountains are, from my understanding, still, I guess, just given the landmass of Siberia, kind of if you divide Russia in half, it's still in the western half, but sort of east of the Ural Mountains. The Trans-Siberia Railroad does not go up in that direction. There's no railroad access. There's, I guess, airport in Magadan, which is down on the kind of Pacific coast, where you can sort of fly in and get some access. But again, just super, super remote. What I found interesting, because thinking about the fact that Canada and the U.S. don't have a single nuclear-powered icebreaker. I think the U.S. has 2 or 3 icebreakers. I'm not even sure. Canada has, I think, 1 or 2, but very limited in terms of running off of diesel. I think you have about 2 weeks of autonomy, which is a little bit hair-raising. the Northwest Passage, basically the Canadian quote unquote like Northern Sea Route, and the American is vastly different. It's much more shallow. It's moving through an archipelago of islands. The ice is far less stable. And there's just not a economic rationale to connect the east and west coast of North America. Who cares, right? We have rail networks that traverse quite easily. We're not connecting European and Asian markets faster than if they went through the Panama Canal. And so there's just not the kind of investment historically, the inertia of that investment, going back many decades, to make the investments to have a nuclear icebreaker fleet, for instance. There are some resources up there, no doubt, oil and gas and minerals. But certainly I don't foresee any equivalent to the Russian nuclear icebreaker program, or even a nuclear powered Arctic. It's there's not an economic rationale, and there's just not the kind of state or corporate capacity to do this. I think Russia's in a very, very unique position in terms of this nuclear powered Arctic development.
Yeah, that's correct, and probably it would stay that way. With nowadays everything is commercialized, and back in the time it was two countries who, then China joined, three countries who could just do it. Like the space race, and the same with the nuclear program, and Soviet Union just did it. And if it would not be developed then, I do not believe it would be possible now. It would be the same reason, guys, doesn't make sense. But the program happened, the experience gathered, and now not to use this technology for Russia is just doesn't have any sense. It's easier to develop this program, and by doing that, basically there is a chance to conquer the market completely, worldwide as well. I'm not saying about the icebreakers or these marine power plants, but anyway, we are still building these nuclear power plants everywhere in the world. Bangladesh, Egypt, where else? Hungary, Turkey. So there is a market for that. So you still have to show the cases, and you still need to win the client.
It is interesting. Rosatom, I was just looking at the numbers, like almost 500,000 employees, again, total vertical integration of the entire nuclear process. 300 subsidiaries, 20 active nuclear builds in 6 countries around the world. I mean, this is just beyond the capacity of any Western vendor to even fantasize about. I guess in Westinghouse's heyday, they probably had 40 simultaneous builds happening in the U.S. And certainly they were involved with Framatome and France's build out. But I think Westinghouse was, at its peak about 150,000 employees. They're down to 11,000. And so we've seen just such, when you actually make those comparisons, you can see the atrophy of Western capabilities in nuclear. Leaving the polemicist hat off here for a second, it is interesting to me. So Russia's dominating in terms of conventional Gen 3 plus pressurized water reactor deployments. But I think, if I'm not wrong, part of the rationale beyond, again, reducing exposure to sanctions and local economic development through using floating small modular reactors in the north is potentially to develop a floating nuclear power plant export market, for countries outside of Russia. And you think about smaller countries that cannot take a gigawatt of power generation, either using the Rhythm reactor as a land-based SMR, or probably more logically as a floating nuclear power barge, may have some potential. What's your opinion on the kind of export potential of these floating nuclear power plant barges once they're up and running in the Pegev and in the Chukotka region?
Oh, it should be a big change in mindset everywhere in the world, first of all. Because when people hear the word nuclear, they're normally scared. And the regulation for the nuclear power ships are quite heavy. That's why, basically, I believe Sevmorput has never left Russia, meaning that it has the possibility to go anywhere. But
this is the nuclear cargo ship you're mentioning?
Yeah. So, but with all the regulations, it's just too difficult, and potentially some areas can require these kind of solutions. First of all, we can say some emergencies, right? So whenever there is a tsunami or earthquake or something, and all the local power plants are damaged, cannot operate, you cannot fix them quickly. Let's say, yeah, it is a possibility. Remote locations, definitely, because infrastructure is everything. And to build up an infrastructure from the scratch is very expensive, no, especially nowadays, yeah. Then these kind of solutions can be commercially effective and can even be accepted by people because it would be somewhere far away, yeah. A very so yeah, and you were talking about the Australian mines. Yeah, very well, possibly. Yeah, but I do not see a possibility of this kind of plant somewhere in Europe or just in the Bay of New York. Not gonna happen.
Yeah, I mean, there's going to be a whole sort of geopolitical element to this in our sort of new multipolar world and the new sort of Cold War. You brought up the word tsunami. Can you talk about, there was a lot of hysteria when the academic Lomonosov was being deployed. This was a Chernobyl on the sea. People seem to have like a unique concern with contamination in oceans versus land. It's just, I guess, a kind of sensibility that we have, maybe our environmentalists have. But yeah, tsunamis and floating nuclear power plants sounds like a big problem, is it?
Honestly, I don't think so. First of all, people now can manage the tsunamis, yeah, meaning that we can predict them. It will not give us a lot of time, but it will give some time to prepare. All the sensors can detect the earthquakes everywhere in the world, and tsunami comes a bit after it. And look, as a sailor, we've managed with the normal ships, we've managed to walk through pretty heavy storms. So 2 points. The icebreaker would never have a problem. That's for sure. And the power plant, the question is where to use it, how to use it. Would it be a safe location? What could be the weather conditions there? And if there could be a tsunami possibility. Yeah. But basically, as we were saying, if the power plant would stay on a reasonable depth, then it's not a problem. So we just need to be away, I don't know, 100 meters away, maybe even enough to avoid any troubles there.
Yeah, I was hearing reports from, I'm trying to remember that massive earthquake and tsunami that was so devastating in Southeast Asia, but people that were out, fishing a few hundred meters offshore, they just felt the tiniest little rise and fall. And then there were, tens of meters tall waves that just devastated the land. So it sounds like in a lot of ways, these are actually safer from the perspective of tsunami than a land-based reactor, as was the case with a very poor decision of where to put the diesel backups at Fukushima, for instance. But
yeah, sure.
It's a bit counterintuitive that being in the water is better than being at sea for someone who doesn't understand these things or doesn't have a familiarity with being at sea. I remember my father was in the Canadian Navy on destroyers, and just talked about the 40, 50-foot waves, and just riding those out. It's absolutely extraordinary. I think we've kind of largely covered what I wanted to. Just any other interesting anecdotes? I believe you said that your father was in the nuclear navy in Russia, and
correct.
Sort of rode out that difficult transition of the collapse of the Soviet Union. And if you have any fun anecdotes, or I just gave you a little taste of my dad's storytelling. But if you wanted to go more in depth with any cool anecdotes, I think it's just a fascinating historical period, and just not something that most Western listeners have a lot of familiarity with.
Yeah, that's true. And I tried to find any information about one story, but I couldn't, honestly, and I don't believe it's documented somehow. But at least once, my father had to go with his submarine to help a remote location with the fuel and food supply, just because something happened with the normal logistic route. So I was a kid, I was like 10 years old back then. No one explained me what happened, but we already discussed that this is quite a problem. And normally all the remote locations in Siberia, they are getting food and fuel basically twice a year, not more. And the ship was stuck somewhere, and they were out of everything. And the nuclear submarine brought them this some supplies to go through a couple of weeks. Yeah. And this was interesting. This was actually the difficult time in 90s, where it was no financing, the salaries were behind, and it was still great for me. Like even in that difficult time, people were able to solve the problem. Yeah, they had to solve the problem. They had to deliver something. They did it. Yeah, they used a nuclear submarine. Of course, it was always nice to have additional training for the team, because at that time it was not so often anymore for submarines to go around the world like it was in Soviet time. It came back, but the 90s were quite a turbulent time for everyone in Russia, and the Navy included. Yeah.
Yeah. Well, thank God he wasn't aboard the Kursk.
That was later. That was later, and that was a tragedy. And this, because I'm actually lived in a small military town, Vidyaevo, and the Kursk was based there. So basically, they were my neighbors. So I already left the place. I was living in Murmansk, and then in I moved to St. Petersburg for the academy. But they all were my neighbors, and I knew half of them. So that was a big tragedy, and one of the biggest secret, I believe, still.
Right. In terms of what happened.
Yeah, what happened. But let's not speculate about it.
Okay, Aleksandr, listen, it was a real pleasure. Thanks for shining a light on a place that is blanketed with darkness 6 months of the year above the Arctic Circle. Very interesting to hear some of your lived experience. I love the anecdote of the polar bears grabbing fish from behind the boat. But yeah, a very unique part of the world, a very unique development that's going on in terms of a nuclear-powered Arctic, and very unique historical and sort of material conditions that are leading to it. So thanks for helping us dig through that. And yeah, it was a pleasure having you on the podcast.
Yeah, thank you, Chris. Thank you for inviting me. First experience for me, and I'm excited to be here. Thank you.
Well, it may not be your last. All right, all the best.
All the best. Yeah, bye.
Today's episode was made possible through a generous donation from the Xerxes Foundation and from listeners like you making pledges on our Substack. If you'd like to join the tribe, please do head over to our Substack, smash that pledge button, or if you would like a tax-deductible receipt, you can hit the donate button and make a contribution through our fiscal sponsor. We genuinely appreciate your support. It is only through your generosity that we are able to continue to offer energy literacy on demand.